Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, my dear students. The last part of Hydroxy compound chapter 8 is lesson 75, phenol. Today we are going to look at how to prepare phenol in industrial setting. Then we want to look at the acidity of phenol compared to alcohols and water. Then we want to look at the chemical reaction of phenol with sodium hydroxide, and electrophilic substitution reaction. Then identification test on phenol, which is FeCl3 solution and bromine water. Here is the general formula of phenol, C6H5OH. On the left side is the Pauling structure, where you have the circle inside the hexagon. But on the right side, there is the cuckoo structure, where we need to use this for mechanism of electrophilic substitution. What is the physical characteristics of phenol? Phenol is a colorless liquid having a low melting point solid. But it has a high boiling point. Why? Because it has hydrogen bonding occurred between the electropositive part of hydroxy group outside of the benzene ring and with the electronegative part of the hydroxy group in another compound. Due to the occurrence of hydrogen bonding in phenol, it is also soluble in water. As you can see in this diagram, phenol on the left here having electropositive part on the hydroxy group outside of the benzene ring is attached or bonded using hydrogen bond with the electronegative part of water. Let's do a revision of phenol naming. Draw the structure of compounds below. So for compound A, 4-methyl hydroxybenzene, let's draw the benzene first. And then we have a hydroxy over here. This makes it a phenol. And at carbon number 4, we are having the methyl group. All right, this is A. And then for B, let's do it up here. We have a benzene ring where, the name is already phenol there. So we're going to put OH on top. At carbon number 3, we have amino group. And at carbon number 5, we have a bromine atom. Okay, that's B. Let's do C. Okay, we draw phenol straight away here. At carbon number 2, we have a nitro compound. At carbon number 4, we have a chlorine atom. Right? And then lastly, we have a diol. So meaning that we have OH at carbon number 1 and then another OH at carbon number 3. Okay, it's that simple. Let's look at the acidity of phenol compared to alcohol and water. So as you can see in the slide, phenol has the highest acidity. The pH is the lowest, followed by water, and followed by alcohol. Why does alcohol has the lowest pH? It's because it produces a conjugate base called alkoxide ion. Alcohol, for example, ethanol, is a very weak acid and only can react with strong base, such as sodium or potassium, like the first reaction that we have learned from the previous lesson 74. Shown to you here is the formation of alkoxide ion. Alcohol will ionize to form H+, and RO minus. R here is a methyl group, alkyl group. It is an electron donating group which will release its electron to the alkoxide ion, RO minus. This will make the alkoxide ion become less stable. So alcohol is less acidic. Phenol is more acidic because it has a resonance effect of the benzene ring. Phenoxide ion is formed within the benzene ring, and the phenoxide ion is stabilized by the resonance effect, whereby the electrons from the double bond will move to the single and go to the double and move to the single, so it becomes alternate single double single double. So that is basically a resonance effect. And when H plus is released, ionized, electron would be more for the oxygen, and this will make the phenoxide ion more stable because the electronegative part, oxygen, has enough electron. Here is the stability of phenoxide ion. As you can see, the extra electron at the electronegative part of oxygen outside of the benzene ring will move into the ring, and then the double bond will move its electron to the single part, and then it's going to move here to make a double bond over here like this, and then it's going to, the double bond here is going to move here, and it will make a negative part here because there's one more electron coming into the benzene ring, and then the double bond here will also move because electron, the one more electron is going to be transferred here. Basically, because oxygen has one more extra electron, that electron is coming into the benzene ring, and the double bond will move around because the extra electron is making it to move. So what happened here is the stability of the phenoxide ion is becoming stronger, and therefore the acidity is higher. Okay, how do we get phenol? By using Cumene process. What is Cumene? Cumene is isopropyl benzene. You have an isopropyl group here attached to the benzene ring. So Friedel-Crafts reaction is when you put propene into the benzene ring using the catalyst AlCl3, and you're going to get isopropyl benzene, which is a Cumene. Then you are going to do oxidation of Cumene, whereby, okay, the reagent is oxygen gas in the high temperature 120 degrees Celsius. We are going to get Cumene hydroperoxide. After that, a process of decomposition and rearrangement is going to happen, whereby sulfuric acid will take away the rest of the atoms from the hydroperoxide and produce phenol. The byproduct would be propanol. Alright, now let's look at chemical reaction of phenol. We have 3, and you have to fill in your mind map in page 295. When you have done with the lessons, you would have your mind maps filled. After that, it will be easier for you to remember the reactions. The first reaction for phenol is the reaction with sodium metal. This is the same as the reaction on alcohol. And the second reaction would be the reaction on sodium hydroxide. It would produce the same product, C6H5O and A. The third reaction would be electrophilic substitution. This is what we have done in chapter 6, aromatic compound. Okay, so the electrophilic substitution reaction that we are talking about on phenol, there are 4 reagents. Number 1 is Br2CCl4. This is the same reagent as the one that we've done on alkene. Remember, electrophilic addition. But as you can see here, the phenol is an orthopara director. So we are going to put Br on the carbon number 2 and carbon number 4. Whereas in electrophilic addition, 2-bromine is going to be coming into the alkene at the restriction carbons of double bond, remember? Right. The second one is Br2H2O. This is also the same reagent as electrophilic addition. But this is not that. This is electrophilic substitution. So 3 atoms of bromine is going to enter phenol at carbon number 2, number 4, and number 6. So this phenol is called 2,4,6-tribromophenol. Right. Reagent number 3 is nitric acid diluted, and we are going to get 2 major products where the nitro compound is attached to carbon number 2, and the second compound, the nitro compound, attached to carbon number 4. The fourth one is when we have nitric acid concentrated. We are going to get 2,4,6-trinitrophenol. Okay, let's look at example 8.17, reaction of phenol with sodium. We have a general formula written here, C6H5OH, react with sodium, and we're going to get C6H6ONA with half of a molecule hydrogen gas. Because phenol has a higher acidity than alcohol, it will react with a strong base, which is sodium hydroxide. So C6H5OH reacting with sodium hydroxide is going to get the same product as previous example, C6H5ONA. Instead, it will produce a byproduct, water. So why does alcohol do not react with sodium hydroxide? It's because alcohol is a weaker acid and alkoxide ion is less stable compared to phenoxide ion. Due to this reason, sodium hydroxide is often used as a chemical test to differentiate aliphatic alcohol with phenol. As you can see here, phenol reacts with sodium hydroxide to produce a one-layer solution whereby the product here is going to be soluble in water. But if we use cyclohexanol, it is not going to be soluble in water Therefore, the observation is 2 layers of solution will be formed. Let's look at the reaction of electrophilic substitution halogenation on phenol using bromine water in tetrachlorocarbon. It is going to produce 2 products because phenol is an auto-para-director. So the name of the product would be auto-bromohydroxybenzene or auto-bromophenol or 2-bromophenol. And the second compound would be para-bromohydroxybenzene or para-bromophenol or 4-bromophenol. The second electrophilic substitution on phenol is with bromine water and water, H2O. Bromine in liquid phase is called bromine water. So it's going to form 2,4,6-tribromophenols. Next, we are going to look at nitration. The first nitration is using a dilute solution of nitric acid. Phenol will form a mixture of auto and para products because the OH group in phenol is auto-para-director. Here is the reaction. As you can see, 2 compound that is produced is auto-nitrophenol and para-nitrophenol. You can also name this product as 2-nitrophenol and 4-nitrophenol. Then we are going to use a concentrated nitric acid whereby we're going to get only one product, which is called 2,4,6-trinitrophenol, and the observation for this reaction is yellow precipitate will form. The last part of lesson 75 is phenol test or identification of a phenol compound. Firstly, we can use aqueous bromine, which is brown in color. If we react phenol with bromine in water, the brown color of bromine will turn to colorless and the compound formed is a white precipitate. The compound is 2,4,6-tribromophenol. The second phenol test is nitration of phenol with concentrated nitric acid, which we have looked at earlier in electrophilic substitution. We are going to produce 2,4,6-trinitrophenol, which is a yellow precipitate compound. Right, there is one more phenol test. This time we use aqueous ferrum trichloride, which is yellow in color. And if phenol is used in the reaction, the yellow color is going to be turned into a purple complex, whereby the ferrum trichloride is going to be attached in the benzene ring. What are the common use of alcohol and phenol? Ethanol is basically a poison. It's a deadly poison, the one that they use in alcoholic drinks for certain percentage of amount. If we use a concentrated ethanol or ethyl alcohol, the lethal dose, LD50, is 10 grams per kilogram orally in mice. So before doing the experiment on mice in biology lab, they would use ethanol to kill the mouse. And what will happen if it is inhaled by human? in case of an accident. It will cause nausea, vomiting, flushing, mental excitement, depression, drowsiness, impaired perception, and so on. It's really a toxic compound. Phenol, on the other hand, is an important industrial chemical. Its major use is in phenolic resins for adhesives and plastics. In medicine, phenols are used as antiseptics and disinfectants. As you can see, here are phenol, resorcinol, and that's used as antiseptic. And another antiseptic also is a 4-hexyl resorcinol. These three are usually used as antiseptic in hospitals. Derivatives of phenol are important as active ingredients in essential oils of cloves, vanilla, nutmeg, and mint. As you can see here, this is the structure of isoeugenol. This one is thymol. This is eugenol and vanillin for vanilla. Interesting, right? Now, your task, if you choose to accept it, is to do tutorial question at the back of the chapter. Test yourself whether you understand alcohol reactions or not. It's for your own good. Please do the homework. Thank you very much for watching. To your Madam Ruby. Assalamualaikum warahmatullahi wabarakatuh. See you in the next lesson. Bye.